This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 174. Today's presentation is a GOES view of 2023 and a glimpse into 2024. We're glad to have presenter Tim Schmit with the GOES-R Algorithm Working Group with us today. He is the imagery lead and he is also a scientist at the NESDIS STAR, with NESDIS STAR in Madison, Wisconsin. I will be facilitating today's discussion following the presentation. Before we get into today's presentation, I just have a few reminders for you. As you just heard, this session is being recorded. There will be an opportunity for Q&A after the presentation, and I'd encourage everybody to put your questions in the chat and we will field them in the order they are asked. If you have signed in with an office account, please specify your full name when asking a question so we can follow up if necessary. We are looking for future presenters. Please contact our TowerS team, Kashad Bowman and Emily Maddox. If you have a presentation you'd like to give, perhaps you're giving a presentation at the AMS and you'd like to give it new life, we'd love to have you as part of the Satellite Book Club if it is appropriate. And the training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Ross Van Til with the Office of the Chief Learning Officer can help with that. I'd like to thank our TowerS team, particularly Kashad and Emily, the Office of the Chief Learning Officer, GOES-R, JPSS program, all of you, and our presenter for being with us today. Before we dive into the presentation, I just want to give a reminder that you can install, maybe not you exactly, but someone at your office can install the TowerS RPM version 24 without an appointment. This RPM has several capabilities, including the Sierra GeoColor and GLM 5-minute data. We've had progress from 94 sites installing the RPM so far. Our goal is to get to 100 this week. So we'd love to have your office be part of that group. The instructions can be found on the TowerS RPM VLab page, which Emily is placed in the chat. So once again, if you don't know about the TowerS RPM V24, please do me a favor, check with your Sue, check with your ITO, say, do we have that RPM installed? And be part of our rollout of satellite capabilities to the field. All right, well, now for the main event, we've got Tim Schmit with the NESDIS Center of Satellite Applications and Research in Madison, Wisconsin. Tim had a lead role in the band selection for the ABI on GOES-R and has played a key science role during the on-orbit checkout of GOES 8 through 18, and hopefully 19 as well coming up, knock on wood. Tim has published over 100 journal articles, several book chapters, and co-edited a book all associated with some aspect of GOES. His Twitter handle is GOES Guy, so he lives and breathes GOES. Tim received his master's degree from the University of Wisconsin-Madison. Go Badgers. Tim, welcome to the book club.
All right, on Wisconsin. So yeah, thank you, Jordan, and thank you, everyone. Thanks not only to the people that are listed on the slide, but everybody that makes these satellite book clubs, and of course, everybody that makes the GOES imagery, literally a cast of thousands. So the image in the upper right hand is not a random date. That's January 4th, a year ago, where the first day that GOES 18 was fully operational. So that was a big day. So what I will talk about today is basically just 2023. So from everything GOES that started in 1975, we'll just talk about 2023. And it's mentioned a glimpse into 2024. If I don't happen to cover your favorite storm, your favorite use of GOES or other satellite imagery and forecasting, A, I'm sorry for that, but B, you can get even. You can sign up for a satellite book club and talk about how you use satellite data in your office. I know I would look forward to that. So the outline is pretty simple. Each month of the year, we'll have one still image followed by one loop from GOES. Again, it was hard to choose, but at least I'll try my best here. So to move it around to show the whole range different geographical coverage, different phenomena, different time scales. So anyways, we start in January, and again, these are all cases from SIMS satellite blog, and I put into the chat the blog that where these cases were summarized. So again, we'll start in the Great Plains, the Dakotas, the great state of Minnesota in early January, specifically January 6th here, and just show a couple different spectral bands here that we can loop through. So first, traditional visible, highest resolution spatially. So you think that's the best, but as you know, so here we're looking at day cloud distinction, which maybe what you look for maybe stands out a little bit, but again, in this case, the day snow fog loop really shows the small scale variability, the changes here, and what we've also got surface observations plot on that. So we'll run through that again. So traditional single band visible, and again, you could just see how the multispectral could bring out more features there. Going on to February. So, you know, oftentimes you might think that the satellite that's closest to your region of interest with the smallest view angle might be the best one to look at. That's usually the case with improved spatial resolution, but also though with larger view angles, especially looking at aerosols, dust, etc., you can get a better view at different times of day from different satellites, depending on the forward backscattering, etc. So here's a case. There was blowing snow, you know, New Mexico, Texas, etc. This is a bit later when it was up in the Illinois, Indiana, Ohio, Kentucky regions. So and a view from goes west. And it, you know, early on in the image, we also see the night microphysical properties, but again, you can see the dust front there very clear as it moves on. I often wonder, you know, we can see a lot of these things from satellite, but you know, how best to really get this information to the people on the ground that are, you know, driving north south on the highway and think, oh, it looks a little bit funny to the west. But anyways, it got that cut out. Of course, March brought the equinox. So here's just showing a you know, with you know, not filling in the dark side, if you will. So the non-illuminated, so the terminator is a lot easier to see as we move on. So you can see we started, you know, at one equinox, went in this case to the solstice and back to the equinox there. Of course, if we went through this for the entire year, we would have seen the terminator come and move over 23.5 degrees this way again. So again, this is just looking at one image at 11Z of each day. That was March. Into April. Of course, you can have severe weather any time of the year, but in this case, an example of prob severe in Oklahoma, it's showing some of the potential lead times, at least using the 25% threshold. As you know, prob severe uses the, you know, changes in ABI data, be it in glaciation, cooling, anvil expansion, but also brings in, you know, RMS mesh and some NWP data. So here we're just looking at the imagery first, and you can see the contours, you know, picking out where the subsequent GLM would see. That GLM, of course, is the blue flash expect density. Of course, you need the GLM to train to help train this algorithm to know what to look for. But again, this is a good way to use GLM before the event to train it, then the ABI to look at the cooling, glaciation, etc. You can obviously do this as humans when you look at the some of the cloud phase RGBs, etc. But again, especially in a messy and busy situation, this can help pinpoint regions of higher interest. Lightning cast is in a similar family, but now this is just using ABI data and just at a given time. So looking at the spatial information from the ABI at one time, it'll give you the percent probability of lightning within the hour. So here was a case. So this image is centered on Colorado Springs, where 2 people were struck by lightning on a golf course. So you could see we're just looking at the clean IR window at first, color enhanced, so the coldest clouds are colorized. And yeah, you can see the maybe an advanced VC feature there, etc. Obviously a big storm moving in, but now we add the contours. So again, you can see a big 75% and then covers this area, and the subsequent GLM really covering the whole area. So just an example of fusion to bring in a lot of different data, in this case for the lightning cast with AI train for the ABI. Moving on to June, of course, this whole summer had a lot of smoke from Canada. This is showing fire power image, and then we can put it motion. Sorry, this showing the 4 micron band 7 from the ABI. You can see they kind of die down a little bit at night here. Now back during the day, they rear up again. And of course, this is some of the smoke that got entrained and came over the East Coast and other parts of the U.S. I could probably have shown a smoke loop from almost every month of the year, unfortunately. But again, this is when some of the major smoke was happening. June, another lightning cast event. One of the things they added was this time series that you can get over various airports, etc. Number of stadiums as well. So you can see a couple things here. The quick ramp up of the probabilities shown in red here, and that preceding the lightning. The lightning is actually in 2 different shades of colors. The be it if it's the 5-minute or well, both are 5-minute, 10-mile or a 5-mile radius from in this case, Nashville International. And again, led to the cancellation of an outdoor concert. There was a earlier, storm that went through. Here was the case again. You can see the enhanced probabilities along with the lightning and increased flashy density as well from the GLM. And we go on to August. So Hawaii, I'd like to show you 1-minute imagery of this case, but 1-minute imagery from GOES 18 was elsewhere at this time. Again, this is just looking at the straight 4 micron imagery. So you can see on this day, the first hot spots really in the center of the island. Coming to now. And of course, then how quickly, of course, everyone's eyes go into the west here, and how quickly things develop there. Of course, the pixels appear larger here just because with the remapping, a number of pixels can be affected, even with fires with one of them. But again, how quickly things can change in a hot, dry situation, and especially if the wind field supported as well. Of course, there were red flag warnings, etc., out for this case. Moving on to September, heavy rain, flooding in New York. So what we're looking at here is a combined where it's clear the total precipitable water from GO 16, and you can see all the moisture lurking off coast, and then the infrared window, channel 13 or the 10.3 micron. There was more information. See the recent FDTD webinar on this topic to go into a lot more detail. But yeah, obviously the moisture offshore, and the entraining over the same areas there in Manhattan, other parts of New York. Could also show a lot of hurricane loops this year. This specifically was Hurricane Otis. Here's the coast of Mexico as it intensified into a Cat 5. So again, you can see the you know the outflow. You know, here we're in nighttime, so we're showing the infrared band, and as it's getting close to shore, and it falls apart a little bit, but again, it's coming in as a Cat 5. Just very impressive animation in that case, Hurricane Otis. Looking back a little bit, this was also a year of some goodbyes. So, you know, GOES N was launched in 2006. It became GOES 13. Of course, had its years of operational service as GOES East. After that was put into storage a while, the U.S. Space Force repurposed it over the Indian Ocean. And just at the end of the year, this was then retired. So it became EWSG1, or Electro-Optical Infrared Weather System, Geostationary 1. Now G2 is out there, which was our old GOES 15. So if you had on your bingo card to see a loop over Madagascar, you'd win here. So again, what was GOES 13, which became EWS G1 infrared window. It's also, you could see this storm went all the way across the Indian Ocean. We're just showing really one of the landfalls that it made over Madagascar. And of course, it doesn't have the time resolution that we're used to with the ABI. Speaking of time resolution, so on the top you'll see visible with severe weather reports, and in the bottom infrared window. It's a tornadic case over the deep south. So in the visible, of course, you see the you know, the bubbling, the you know, overshooting tops, and very cold temperatures in the infrared as well. And you can see here, yeah, sure enough, 30-second imagery with this case, with overlapping mesoscale sectors. So that was December. If I missed your favorite day, here's how we're going to have it try to be covered. So basically, one image per day, 1730 UTC of the water vapor band, one of the water vapor bands on the ABI. So again, 1 year going by quickly. So that's a little bit of a recap of 2023. I promised a glimpse into 2024. So we'll talk about two things. Number one, the total solar eclipse. And that's the path is shown here. Basically Texas up through the northern part of New England. The colors is a mean percent clear from time from GOES over the years, specifically from 1995 to 2023. It doesn't make it a forecast, but it does show you in general, you tend to be clearer in Texas than in New England in April. And there's a blog on this case, including, so for the climatology, we only went back to 1995, but with this just showing one image per day, we were able to go back to 1997. So here's GOES 5, so just GOES 6, GOES 7, all remapped into the same projection. Then we move to GOES 8, 1995. Again, it really is, it does vary year to year depending on the weather. GOES 12, and we get into GOES 13, and finally GOES 16. So again, a little bit of data. I think I mentioned, and again, we've had some SMS1 and GOES 3 and SMS2 at the beginning of the loop. So so get ready for that. If you can't see it, you can see the shadow. What's the shadow going to look like? Kind of like it looked like in August of 27. Obviously, the path is going to be different. It's going to look like this, but you can also see how when the sun's getting turned off here, you can see some of the cumulus developing here, and then going away with less solar radiation, and then coming back. And then, of course, you know, even here down in Oklahoma, you could see the cumulus forming, kind of going away, and then coming back. So looking forward to that. April. Other thing looking forward to is the launch of GOES U, slated for April 30th. Recall after its post-launch checkout, it'll become the GOES East satellite, replacing GOES 16. The loop here, you can see the plume, and this is from the GOES 17 30-second imagery from a research meso request. You can see the plume, and of course it gets blown in different directions with height there. So hopefully, if the weather's good, we'll also have some 30-second views of the GOES U launch as well. So looking forward to that. Speaking of GOES U, there was recently what's called the data operations exercise, where they basically took, in this case, GOES 16 data, ran it through, and produced files labeled as GOES 19. So here's a glimpse. Of course, it's just GOES 16 data, but showing that various software works with GOES 19 files, be it Mercatus X16 panel, GeoColor, TrueColor, or two different views from AWIPS. So thanks for everybody for making that happen. So in summary, I think blogs can be a great resource to refresh on various topics in the near real time. I've labeled two of them here: the UW-SIM satellite blog and the satellite liaison blog. Mostly Bill Line does. Of course, ABI shows a range of phenomena in time and space. So from half kilometer to planetary scales, from 30 seconds to daily. I've showed mostly imagery and some level 2 products, but of course there are also a host of level 2 products as well. And as I put in the blog, in the chat, there's a blog on this case. So with that, I would take any questions.
All right, thank you so much, Tim. A big virtual round of applause. Just a few reminders while we let comments and questions come in for Tim in the chat. Please stay on. We're encouraging participation from our field offices and regional headquarters. And as a reminder, please specify your full name when asking a question. Continuing with the Satellite Book Club next week on Thursday, January 25th at 12 noon Eastern Time, we're going to have Alex Edwards, lead forecaster at the forecast office in Tucson, Arizona, and Stefan Shively, meteorologist from the Tampa Bay office, to discuss the 2023 hazardous weather test bed satellite spring experiment. So I hope for those of you that have to drop off now that you'll join us again next week. Also, as I mentioned at the beginning of the call, with regards to the Tower S RPM, or if you have any other questions for our Tower S team related to the book club or configuration of satellite products, there is the contact information for our Tower S superstars for customer service, Kashad Bowman and Emily Maddox, or find us on the Tower S channel as part of the NWS internal Slack workspace. Tower S, we're here to help. So if you have anything related to satellite, hopefully we've given you an avenue to contact us. All right, so let's get to some of those questions. And we're glad to see almost 90 people on the call today, and thanks to so many of you for sticking around. Our first question today comes from Bill Line. Bill, a colleague of yours in NESDIS Star, says, great presentation. I think we all agree with that. What is your favorite ABI band?
One of the toughest questions here. Well, of course, if I only had to pick one band to, well, first of all, bands 1 through 16 are my favorite band. If I really could only pick one band, I would probably pick band 13, the clean IR window. But I do have to say I'm somewhat partial to the 7.3. Towards the end, we spectrally tweaked that a little bit so we could still see water vapor, but we got a better job of looking at SO2 with it as well. So, and I had a hand in that. So great question, Bill. Sorry, a tough answer to give.
All right. I know what my favorite band on the GXI is going to be, but we'll let people guessing for that one, Tim. And Dan Lindsay said there's only one correct answer to Bill's question, FYI. All right. Well, if you have a favorite ABI band, we can turn this into a group discussion. Please go ahead and put your favorite ABI band in the chat. Moving on with a question from Eric Stevens. Any chance for GLM to survey higher latitudes in the next GOES series, or are the pixel broadening and parallax unsolvable problems?
I don't know the details. I know that it's going to go farther north. Jordan, do you or somebody else online know how much further?
This is a good question because I'm not sure how much we can say at this time. I think we're still in blackout for the lightning mapper.
Okay. Yeah, we could say
so,
what the requirements are.
Yeah.
But we'll have to bring Scott Roloski or someone to talk. I'm just curious if there's an image. So I think you're probably seeing this GeoXO page. Just wondering if they might have a coverage plot over here. Okay, this is on a web page, so it's got to be true. The potential lightning mapping improvements include finer spatial resolution and temporal resolution and expanded field of view further north to include Alaska. Additional improvements would be realized through advancement technology. But again, it's still early in the process. So I'll put that chat in there too. So there's hope, but it's still, of course, being formulated.
I guess it's fair to say, and Dan Lindsay says in the chat, the answer to your future lightning mapper question is maybe. Scott Lindstrom points out the website does say potential improvements. I think it's fair to say, we're not telling anybody information they don't know. that there is a capability, an engineering capability to scan the whole disk if we opted to, but that doesn't necessarily mean that that is the solution that we're going to settle on. So stay tuned. We look forward to sharing more about the LMX and its capabilities once that instrument award process is complete. So, and thanks, Tim, for providing the link to the lightning mapper. And I will say, in the interest of service equity, for those of you that are listening from Alaska region and even Pacific region, we are working very closely to make sure that all weather service offices have as close to the same capabilities as is feasible. All right, let's move on. And a lot of lightning questions, Tim. I don't know.
Yeah.
T. Maria wants to know, why don't you show GLM data on the lightning case plots, on the lightning cast plots? I'm sorry.
Well, I guess I'm a little bit confused because I thought we did. So I guess maybe it depends on which case talking about. But for example, like, I mean, this is a lightning cast, and it's showing, I mean, this is when the GLM started to have it, and it shows its count here in blue. And then in the subsequent loop, just play that.
Yeah, Tim, I was thinking about the 2D plots that you showed. Maybe they were on there and I just didn't see them.
Yeah. So again, I think there were it's kind of a blue on black, if you will. But that's the plan here. The idea is to show that, you know, when you can get a lead time compared to when the observations come.
Thanks.
All right.
Yeah.
Thank you.
Or the new name, lightning case. I like that.
We have a question from the other Tim that says, Tim, for the non-geotypes on the book club, and we can guess who the other Tim is, can you summarize the deltas that you are looking forward to with regards to the GXI?
Yeah. I mean, number one, I mean, I love the continuity that we're going to have, and, you know, being able to evolve, you know, what we already have with ABIs. But, you know, really looking forward to, I believe, Jordan's favorite new band, lower level water vapor band on the ABI. It doesn't mean we don't need a sounder, but it does mean that we can get that information sooner and have it for the wings. So spectrally, the two new bands, spatially, you know, may be having, having a near 1 kilometer for fires. You know, back in the old days, we showed 4 kilometers, and oh, look how good, much better we're going to do at 2 kilometers. And there's a factor of 4, a huge improvement. But we're going to see that again for the finer resolution in the 4 micron. Being having had a finer resolution in one of the water vapor bands, I think that'll help with turbulence, looking at these smaller scale waves. And so I guess other than the spatial, spectral, and temporal components, that's just it.
All right, sounds good. Ken Cummins asked, how small can a fire be to show up on band 4?
Let's see. I know Chris Schmit gave a answer in hectares, which I can't do. It all depends on how hot the fire or the hot spot is. I mean, it shows up. For example, we've seen them on rocket plumes, and you know, I mean, a rocket's not very big. So again, it's how much energy, you know, can be shown up there, but I know we've seen, you know, gas flares as well as night, as well as fire.
Yeah, maybe I'm not understanding what slide this was in reference to. Isn't band 4 the Cirrus band?
Yeah, yeah, but yeah, I don't know what specific case.
Maybe Ken, if you can follow up on what they said
Yeah.
they were there.
Yeah,
Uh,
the bottom line is really you can see a hot spot in each of the 16 bands depending on its background, how hot it is, time of day, solar interference, etc.
okay. Yeah, good point. And Tim and Ken says there were some early slides with fires. Yeah, I think the go-to band for fires tends to be band 7, and then depending on the heat, you can sometimes see it, especially at nighttime, down into band 5. And Dan says, yeah, if the atmosphere is really dry and the fire is really hot and relatively large, you should be able to detect it with the 1.38. But that may, I think the atmosphere effects in the 1.38 may make some challenges as a go-to approach for folks listening in the field. You probably got better options than the 1.38. Okay. Yeah, house fire sounds good. Okay, next question here from Babla Plant. Well, first I should point out Eric Stevens, I think in response to our favorite band question, he said the veggie band. And I think folks that work in fire weather can probably appreciate that. Next question comes from Bob LaPlante. He said, can you provide the link for your composite mean cloud cover and video on April 8th? And I think
Yep.
you did that. Yeah.
Yep, I did that with a slight caveat. This does have this loop in here. This is you can actually. This is a little bit nicer, so you can stop it and go it faster and annotate it and all that fun stuff. I don't believe we've put the climatology figure as part of this. I was thinking about doing another blog, but maybe I'll just add it in onto this one. So give me a little bit of time, but I'll put the a link to the climatology figure as well, which is out there, but I don't think it's on a blog.
All right. Thank you so much. And we're winding up here. I don't see any questions. If you put a question in the chat, we had quite a few discussion there, so please put it back in there if I missed it, but I think I got them all. So appreciate all those questions today. Assuming we don't get any more questions here, was there any cases in from 2023 that you didn't have time to include, or you just
Yeah,
couldn't go
right.
back and load that
Yeah.
data up?
Yeah. I wanted to do 2 of these because, of course, there's ice flows, which is always cool to watch. I didn't get any volcanic ash plumes, either be it of suspended material or new volcanoes. And as I kind of mentioned, there's this whole world of level 2 products, be it turbulence, other ones that could help and support what you're seeing in imagery. For example, there's that readout feature where you can be looking at the RGB and say, oh, I'm not sure if that's dust or not, but then you can have the level 2 product give you, yeah, that's probably dust. So anyway, the answer was yes, but again, they had a lineup from each year or each month of the year as well.
Sounds good. And is there any one web page that links all of this GOES info for folks in the field?
That's a great question. So I curate this page, which try to just have a link of where people can look at imagery, get historical GOES imagery about the lightning mapper, uh, papers, more than you ever want to know about calibration, and including the event log. If you want to get data, be it from class or the cloud, It's really just one click away. A little bit about space weather, software, and some training in information and level 2. So anyways, that's where I tried to put, when people ask me a question about GOES, I try to put it out there so then it's a resource.
One of the things, Tim, that kind of did some informal asking around issues related to GOES data that still exist, or at least that we think our forecasters have a lot of questions on. And parallax was one of those things that came up. And I see here you're bringing up a web app for some of the great space weather data. It's an active space weather period. But yeah, I know you have some web apps on here that might help with those questions.
So let's see. Let's say you're up GOES West, and you have a feature of interest that's at 50,000 feet or 15 kilometers. This page, again, this is just the theoretical calculations. You can also show your readout here. So you know, depending on where you are, it's somewhere between, let's say, 20 kilometer of again, it's not an error, just an offset. But again, you need to keep it when you're comparing things. So 20 kilometers to 30 kilometers to 50 kilometers, you know, to 80 kilometers and more offset. So we have this for a couple different regions, from east and west, full disk, some different sectors. So again, if somebody wants to get basically the concept and how you want in your head to adjust things, of course, it depends on where you're looking and which satellite you're looking from and how high your object is.
All right, super, Tim. Well, this was fantastic. Thanks for stimulating a lot of discussion today. I really appreciate it. Thanks for everybody who hung on the line through this discussion period here. As a reminder, the Satellite Book Club is going to be continuing next week on Thursday at our normal time. We're going to hear about the Hazardous Weather Testbed 2023 Satellite Spring Experiment. So I hope you'll be able to be back to join us next week. And in the meantime, once again, we have a great Tower S team. Please don't hesitate to get in touch with them. With that, we will wrap it up today. Thanks, everyone, and see you next week.